It's that time again, folks. We've got new CPUs from Intel. These are the 4th generation Core series processors, codenamed Haswell, and I'm going to walk you through what's new and fascinating about this CPU from Intel. First thing that's new about these new CPUs is that they use an all-new socket. LGA 1150 is different from the older LGA 1155. There are 5 fewer pins, but don't let that fool you because pins do not correlate directly to performance. We've also got an all-new chipset, the Z87 chipset, to go along with our new Haswell chips. Next up, we've got improved new lower power consumption. There are new C-states supported by these processors that allow them to consume, I've seen an entire system pulling less than 55 watts from the wall at idle, which is incredibly cool as an overclocked system. We've also got new instruction sets. FMA3 and AVX2 are now supported, providing performance improvements in certain applications, assuming the software supports it, and there have been some architectural tweaks. No new process technology this time around, but there is a new architecture here that includes a bunch of really cool stuff. Dramatically improved graphics processing performance, as well as a shared level 3 cache between the CPU and the graphics core. So what exactly do you improve about the graphics that are built into a CPU? Well, for one thing, last generation Intel took their unlocked overclocking gaming CPUs and put the best onboard graphics on them. This time around they've gone, oh, okay, no, those guys are probably going to get dedicated graphics cards. Let's focus the better graphics on the ones using BGA chips or mobile chips. So the 5000 series graphics are going to be found in things like all-in-ones, and 4000 series graphics, which are still improved over last generation, are going to be found on the desktop socketed variants. Next up, we've got VQE and MFC. So that's Video Quality Engine, as well as their multifunction codec has been updated. These are intended to provide a better HD video playback experience and at higher quality levels with less CPU utilization. So that's something you can improve about onboard video. Make it use less of the actual CPU power itself. This is going to be a concept we're going to see a lot of over the next little while. Intel has also added 4K support on both DisplayPort and HDMI, although it should be noted that you're going to want DisplayPort if you want to run at high refresh rates. And last but not least, they have also continued, well, okay, I guess this isn't really new, but they've continued support for QuickSync technology, which allows you to, again, we're seeing that theme, offload the processing of transcoding video to the onboard graphics as opposed to using the CPU. I mean, all of that is in addition to the fact that it offers anywhere from 2 times to 3 times the onboard graphics performance of the last gen, and you can now experience triple display outputs on your onboard graphics with less latency than before, which is definitely great for guys who are into productivity. This right here, new motherboard, new socket, new platform, new chipset, all of that good stuff. What is different about Z87? Well, to be perfectly honest, Z87 is mostly a tweaked version of Z77. It's not, flipping the world upside down like we saw with the release of Conroe, where it's like, whoa, there's a memory controller built into the CPU. Whoa, it's insane. The only real difference that's being made here is more I/O. So for example, you're getting up to 6 native USB 3 ports now, up to 6 native SATA 3.6 gigabit per second ports now. We've still got support for those cool technologies like Lucid Logics, where you're using the onboard graphics and the desktop graphics. We've still got support for Smart Response technology, which is their SSD caching. And we've got, this is the big change on the motherboards. We've got VRM built into the CPU itself. What this means is that you are going to be less dependent in your overclocking endeavors on the power delivery system of the motherboard, at least to a point. For anything extreme, you're going to want a super extreme motherboard, same as before, because most of the voltage regulation, or much of it, is done on the CPU itself. So there you go, guys. Most of the same themes are still here in terms of motherboards. So, an ASUS ROG board is still going to have extra bells and whistles that are really cool, much like the last gen, but we get a different name, we get a different socket, and we get a few more bells and whistles. But I've spent almost no time talking about the actual chips themselves. Pretty much, you get a performance improvement. The clock speeds aren't really moving much. In fact, the 4770K has exactly the same clock speeds as the outgoing 3770K. The improvements are coming from that new architecture. So which one do you buy? Because there's all these different variants. In fact, there are 3 different Haswell 4th Gen 4770s in front of me here right now. I have the 4770K, I have the 4770, and I have the 4770S. And there are bound to be more variants at some point too with different suffixes. So what do they mean? Okay, well, we'll start with the regular one. The regular 4770 is vanilla. It actually is clocked slightly slower than the 4770K, although they all have turbo boosts, they're all i7s, they all have hyper-threading. And that's pretty much it. Okay, the K is your unlocked overclockable CPU. It has an unlocked multiplier, meaning you can easily just turn up the multi, turn up the voltage, and have a great overclocking experience. I've seen Haswell chips. In fact, my sample does about 4.7 gigahertz on all 4 cores without any difficulty, so the platform looks pretty overclockable. But as always, guys, your mileage may vary, it's luck of the draw, and with the built-in VRM component on the CPU, that can increase heat output as well, so you may need an awesome liquid cooler in order to get the most out of overclocking the CPU. Then we've got the S variant. This is just like the vanilla one, except lower power and lower clock speeds again. So this guy right here is a 65 watt part, and we are expecting to see Haswell parts that are even lower in terms of power consumption, which means whether you're on a desktop or whether you're on, well, particularly something like a small form factor desktop, you don't want a lot of heat output or power consumption, something like that could be a great choice because you'll get most of the performance through turbo boost of the higher end chips, but with a power savings advantage. Now Core i5s. So in front of me here I have the Core i5 4670 and 4670K. No S variant, at least here on the table of this one, but the differences are pretty simple. Core i5s do not have hyper-threading. So you got 4 cores, 4 threads. On an i7 you got 4 cores, 8 threads. They're clocked a little bit lower than their i7 equivalents, but for someone like a gamer, these ones are often the ones to go with because most games don't take advantage of more than a couple threads anyway. Lower down than that, we've got a couple more i5s. It's going to be all i5s and i7s at the start, with the lowest end one being the 4430 Core i5. And these are for if you're looking to save some money, you again want to have the Haswell architecture, you want these advantages like better multi-display and all that good stuff, better onboard graphics. These are the ones where using the onboard graphics starts to make sense because they're coming in at a lower budget. So we've got pretty much the mid to high end covered so far, with i3s presumably coming later. Thank you for checking out our Haswell primer on NCIX Tech Tips. Don't forget to subscribe for more videos like this from ncix.com.